PC system. Floppy disk is capacity, high speed, long-term storage device in our PC system, and that is the hard disk drive. We're going to take a look at how a hard disk drive works and look at how we install it in our system. Now,
they're quite a bit more expensive, so a lot faster than IDE, hence the popularity. Now, another factor you need to keep in mind with your hard disk drive, in addition to interface, is capacity. Storage space do you need? I would recommend a bare minimum of 40 gigabytes. And you know, if you have the money, spend it and get a real big hard drive. No matter how big your hard disk is, you always end up using every last bit of it. Another thing you want to keep in mind is how fast does that hard drive spin. The faster the hard drive spins, the faster it can read and write data. Low-end hard drives run at about 5,000 RPMs. Middle of the line hard drives run at about 700. These are really nice. These are much snappier than the. I would set this as my bare minimum. And then if you really want to spend some money, you can get a 10,000 RPM hard disk drive. Once again, you're just increasing the performance of the system. Now, to install an IDE/ATA type, there's a concept you've got to know. Channel, master, and slave. Let's first talk channels. What you need to understand is that your motherboard has two IDE channels installed, both two different connectors. The one is the primary and the other is the secondary. To each of these connectors we have two plugs on it, meaning that our PC system maximum or IDE devices in the system. When I say IDE, I'm talking about IDE ATA. On channel, there has to be a master drive and a slave drive. It's politically incorrect, but that's what they're called. Each channel has one master and one slave, okay? You cannot have two drives on the same channel. You cannot have two master drives on the same channel. One drive is the master, the other drive is the slave. Now, you might be asking the question, well, what if I only have one drive in the system? Well, in that case, we just as the first drive on the primary controller, and we set it to be a master. Now, here's another point of confusion. Many hard drives will have actually things. Instead of having master and slave, they'll have a third one called single. So we can set it to be a master drive, slave drive. On those types of drives, if there's only one drive in the system, instead of setting it to master, we set it to single. Other drives that don't have the single, if there's only one drive on the channel, you set it to be the master. Let's go and install the hard disk drive for the system we're building as the master drive on the primary IDE channel. First thing we need in an IDE/ATA type hard disk drive is set the master-slave relationship on the hard drive itself. And this is done using jumpers. Now, most good hard disk drives will have a legend on them somewhere that tells you how to set the drive in a given way. Take a look at this hard disk drive. It gives us a legend here. It tells us how to set the drive as a master drive. It says if we want the drive to be a master, then we need to put a jumper on the jumper labeled DS. Let's go ahead and do that. Now, remember from the table that the jumpers on the far right side is the DS jumper. If we want to set this drive to be a master drive, then we need to place a shunt, such as this one here in my fingers, on that far right set of pins, like this. By doing that, I just set that drive to be the master drive. Now we can install that drive on either our primary or our secondary IDE channels on the motherboard. However, the general rule of thumb is that you set the main hard disk drive in the system to be the master drive on the primary IDE. That's what we're going to do next. With our drive, master drive, the next thing we need to do is actually physically install the drive in a 3.5-inch drive bay in our case. Now, here's our floppy disk drive. There's actually a second floppy disk drive bay right here, and then there are 1, 2, 3, 4, 5 hard disk bays right here. So my hard disk drive, I'm going to move the floppy disk cable out of the way. I'm going to install it in this first hard disk bay right here. So there's some little tabs that the hard drive rests on. Slide it in, and you just want to line up the hole in the hard disk drive holes in the case and get 2 coarse threaded screws. Now I need to put 2 screws in. Okay, I've got the front and the back holding the hard drive into the case. Now I need to connect my hard disk drive to my IDE pieces on the motherboard. I have 2 of them. I have a black one and I have the blue is our primary channel. Black connector is our... Now, this brings up a very important point. I have 2 IDE cables here. I have this one, and I also this one. They both have identical plugs. Which one should I use? Are they? Well, if you look very carefully, your left has fewer wires than the one on the right. This cable over here is designed for old IDE drives. It only has 40 wires. The cable here on the right actually has 80 wires, and for newer IDE/A type drives. If your builder has purchased a newer hard disk drive, make sure that you're using this newer type of cable and not this older one. The first thing I need to connect my IDE to my primary IDE connector on the motherboard. Now notice that this connector is keyed. Back in the old days of IDE, really easy to put the cable on where it's become a key to keep you from doing so. Also notice that there's a pin missing right here. Okay, there's a little gold pin.
These two key and that missing pin keep you from installing your IDE cable backwards. So I take my ribbon cable and I find it and I line up the notch. See the key on the ribbon cable needs to with the hole, the notch in the motherboard connector, and then I just simply push it. Let's go ahead and connect the other end to our IDE hard disk drive. Okay, so the other end of our cable, and we plug it in the connector on the back of the IDE drive right here. Now, just like the other one, it's pin missing. This is the connector, and it's keyed as well. We can't put it in backwards. Now, the question I get time. There's actually two different connectors on the IDE cable. We can have a slave drive, right?
The connector is plugged into the master drive. The connector is plugged into this. You know what? It doesn't matter. The master-slave relationship is by this jumper. It's not controlled by the position. I'm going to plug my IDE ribbon cable in until I feel it firmly down the bottom. Now there's one more task. Notice right here that there's a power. In order for this hard drive to work, it's got to have current power supply. It's got electric motors that got to run. In order, we pick one of our large connectors, such as this one. The Molex connector is beveled so that it can only be inserted in direction. Look at the connector in there and find the correct, and then simply push it on. Now our IDE hard disk is properly. There is one more thing we need to do before we can use it. Let's go into our setup program and configure our BIOS with the appropriate parameters of the hard disk drive. We're not going to do that yet. We're going to do it in one fell swoop. We'll set our floppy disks and everything else all at once. Our hard disk drive installed, the next thing we need to do to build our is install an optical media drive. Now many people's heads when I say the term optical media drive, they say, what in the heck? Optical media drive, what are you talking? Well, an optical drive is a fancy name for either a CD drive or a DVD drive. Let's talk about how an optical media works next. Now an optical drive is binary PC data on the surface of an optical disc, a CD or a DVD. On the bottom side of any CD or DVD are areas of the disc that reflect light and areas of the disc that don't. By using reflections and non-reflections, we can encode binary zeros. In order to read this information off of a disc, a head inside our optical drive that shoots a laser beam at the bottom of the disc. Now some areas of the disc reflect, 0. Some areas of the disc do reflect, a 1. The reflection comes back looking like this, a series of dashes and blanks. The head inside the optical drive reads those reflections and reconstructs binary PC data from it. With that, let's take a look at the considerations you need to keep in mind when selecting an op for your system. The first choice, obviously, that you're going to have to make is, do I want a CD or do I want a DVD? The CDs only hold 680 or so megabytes of data. A DVD drive, on the other hand, can hold a lot of information, 4.8 gigabytes of data. If you decide to go with a CD, you also need to what type of CD, because there's actually several. The first type is called a CD-ROM. This is the earliest type of CD optical media drive, and ROM stands for read-only memory. It could only read disks. It couldn't read disks. If you wanted a writer, then you need to look at one of two other options. One was called a CDR. This was the first type CD burner. Well, one of the problems with the CDR is the fact that once you wrote data to a disk, it was fixed on the disk. Nothing you could do if you wanted to change it. To address this limitation, the industry came up with the CDRW drive. The CDR drive can read a typical CD-ROM drive, write to a CDR disk, and it can also, with a CDU disk in the CDRW drive, actually write data to the disk, erase it, whatever you want it to do. Just like with a CD, if you're going to pick a DVD drive, you need to pick a type.
And there are types. The first, of course, is the DVD-ROM, which is like a CD-ROM. It's just it can only read data, it can't write. If you wanted a recordable DVD, however, you had a plethora of choices. The first one was the DVD-R, DVD recordable. Later on came the DVD-RW, like a CD. You can burn information, erase it, rewrite information, and so on. Enhancements were made, and you had the DVD plus RW. In the last couple of years, we've seen DVD plus minus RW drives that allow either type of disc to be read or written to. With that, let's take a look at how we install a DVD in our PC building. Now, for them, I like with an IDE drive. Because it's an IDE drive, I have to set the master-slave relationship. We're going to make this the master drive on the secondary IDE channel. So the first thing we need to do is to set our master-slave relationship. That is done with this set of jumpers right here. This set of jumpers is slave, this set of jumpers is the master. Notice that it's already set to be the master drive. There is one other connector you need to be aware of, and this is this one right here. This is our analog audio connector. We're going to put a plug in here and connect it to our motherboard. What that allows us to do is to put a traditional audio CD in our CD drive and play that audio CD and have the music come out through our PC system speakers without really having to do much with the CPU. So let's go ahead and put this drive in the system. Now, what I need to do actually is remove a front cover from the case itself. You'll find that with the given case you might have 1, 2, maybe even 4 different slot covers that cover up each of these 5 1/4 inch drive bays. And again, depending on the type of case you pick, there may actually be a metal plate cover right there behind the plastic plate cover, and you might take that off too. If you find one of those, just grab a hold of a screwdriver or a pair of pliers and wiggle it till it comes loose. Then pop off the plastic cover and we're ready to put the drive in. Now, I've already done that on this system. So I'm going to take my drive, and I found with CD drives it's usually easier to insert them from the than from the rear because they're so long. And I've selected this bottom 5 1/4 inch drive bay to insert the drive into. As we did with the floppy disk drive, I've got one hand over here with my thumb on the front of the case to tell me when the drive is at the right depth. And once I get that, get 4 fine thread screws and screw them into the holes to secure the drive in its place. Now that we have the drive physically installed in the PC system, we now need to connect all the different connectors. We need to connect connector, we need to connect the IDE interface, and we also need to connect. First thing we're going to do is work on the IDE interface. Remember we said that we decided this would be the master drive on the secondary IDE channel. I checked my motherboard edition, and this connector right here is my secondary IDE channel. So I've got my IDE ribbon, and I'm going to plug the first down here. Remember the IDE connectors are keyed, so you can't put them in incorrectly anymore. Be able to. Now I need to connect the other end of the cable into the drive itself. However, before I do that, I'm actually going to plug the drive end of my analog audio cable port right here. The reason I'm going to do that is because if I hadn't put the cable in first, over here it's going to cover that up and you're not going to be able to see it. So, in my box CD-ROM drive came in, I find my audio cable plug right here. So I'm going to go ahead and plug this cable. Now you're probably saying, well, which way it goes? Actually, you know what? It doesn't, because all are is the right channel and a ground. So if you get it backwards, the only problem you end up with is that your left channel plays out of your right speaker and your right channel plays out of your left speaker, and it doesn't really make any difference. With that, let's go ahead now and put our IDE cable into it. Remember with IDE, it doesn't matter plug you use as far as master and slave. We're going to use plug for this one. We've got a red wire here indicating our pin 1 direction, and it is so I can't put it in backwards anyway.
But the told you earlier with floppy drives also holds true with hard disk drives if you're ever in doubt. 99.99% of the time, in fact 100% in my opinion, the rear pin 1 is always closest to the power connector. Okay. Now our drive is our IDE channel. It's configured as the master drive on our secondary channel. Let's and apply power to it, and then we'll connect the other end of our audio cable. So I find Molex plug, the same plug that was used to connect our hard disk drive to power. Use the connector. I notice that so it can't be inserted back side down. Get the correct orientation and plug it into the connector. Our drive is ready to go. Let's go ahead and plug the other end of our audio cable into our motherboard. Now I checked board document and I found out that the connectors for ammo right down here. Now there's actually two of them that you can see, a black one over here and a white one over here. Remember I said that there are multiple types of audio plugs that have been used over the years. This is a good motherboard. It has sizes just in case I've got the wrong one. With this one, I take the other end of my audio cable and I connect it into the black connector. I know my hand's in the way and I apologize for that. There's just no other way around it. And if I'd been smart, I would have actually done this before I put that expansion. But with a little bit of skill, got our audio connector for our CD-ROM drive connected into the appropriate port. Now we can listen to our CD-ROM drive as well. At this point, our CD-ROM drive is almost ready to go. We do need to go in and enable the master drive on the secondary IDE channel system BIOS, but we're not going to do that just yet. Okay, we're almost done. We've got our motherboard in, we've got our CPU in, we've got our memory in, we've got our storage devices in. We're almost, however, there are still a few things left to do. The problem we've got right now, as it is, the fact that we have no way of communicating with that computer. We have no way of saying input that the system and the hardware can process. To do that, we need to install input devices. These include devices such as the keyboard, the mouse. Let's go ahead and take a look at the keyboard. Now, if you've used computers at all, you're already familiar with the board, right? We have a series of keys here, and magically they appear on the computer. How does it work? Well, the keyboard underneath all these keys has what's called a keyboard scanning chip. Basically what the keyboard scanning chip does is sit there and wait to see keys pressed. Like I just pressed the R key. The keyboard scans the fact that the R key was pressed and sends the R key through this cable into the motherboard, processed by the CPU, and then the CPU does whatever it is the operating program to do when the R key is pressed. Could be put the letter R on the screen, could be a menu shortcut, or whatever. When you're ready to connect the keyboard that you've picked out, locate the keyboard port right here on the back of the. Now these are called mini DIN connectors. There's two of them. The bottom one that's colored purple is for your keyboard. The upper one that's colored green is for your mouse. And this is what the plug looks like. All you have to do is simply plug it in like that. Not much to it. Now let's take a look at the mouse. The way the mouse works, I'm going to flip this over so you can see that there's a ball here. When we mouse, it causes that ball to. I'm going to take this cover off here. You have to get a little bit of lint to pop it off. You can see there's the ball in there. Now if I drop that ball out, there are different sensors. There's one right here, and right down here. When the ball rolls inside here, also those sensors. As it rolls those sensors, it sends electric signal through its core to the PC. which way is the mouse moving, and it's all based on the X coordinate system. Moving this way, or are we moving this way, or a combination of both? Changes in the XY coordinates are transmitted to the PC. It does what it's programmed to do with those inputs. Usually it moves the cursor on the screen a given amount. To connect to the PC system, this green connector right above the keyboard connector. Occasionally you'll come across a motherboard or case that doesn't label the mouse and the keyboard. Motherboards before where these two are black and you say, oh boy, which one's a mouse, which one's a keyboard? Generally the lower one's the keyboard, the upper one is the... Now most mice are color coded. Notice that the keyboard is purple and the connected into was purple. Mice are that way too, except for some. For instance, this one. This one uses a generic silver and gray connector. But we know it's a mouse, so we can plug it in right there like so. Okay, making stellar progress. This PC system from a physical standpoint is all there. Everything's connected, it's all wired up, it's ready to be turned over. Before we can go ahead and install a system, there's still a thing we need to do, and that is to go in and enter our basic input-output system, or BIOS. Remember back when we installed our floppy disk drive, our hard drive, and our DVD drive, that we said that before we can use those we actually have to go into the CMOS setup program, our BIOS, and configure various parameters so that the motherboard can with them. Well, that's what we're going now. What is the BIOS? That sounds like a funny name. The BIOS is actually a chip on your motherboard that contains a whole bunch of little teeny tiny programs that are used by the CPU to allow it to communicate with everything on the motherboard, that allow it to communicate with RAM, that communicate with the keyboard, allow it to communicate hard disk drive, that allow it to communicate with your floppy disk drive, and so on. Before you do that, you have to set up some parameters. The CMOS chip stores the parameters that the BIOS needs in order to communicate with these various devices. Every board has a special little program in the BIOS, the setup program. And when you first turn the system on, a little message will appear on the screen somewhere that press and then a certain key to enter setup. When you press that key, that little program is loaded out of the BIOS, and it allows you to go in and configure different parameters. You see it says press delete. I press my delete key and my setup program comes on. Here's the current date and time. Now here's where I need to configure the type of floppy diskette I have installed in the system. By default it was set to a 3.5 inch 144 megabyte drive. Common type of floppy disk drive in most PC systems. It's good. I'm going to hit enter, select that. Notice right here that it already picked up my hard disk drive. Well, how did it do that? Notice right here under type it says auto. When the motherboard was shipped from the factory, the motherboard manufacturer set all of these IDE types to auto. Now auto means that the motherboard, when the system boots up, is going to go out and check for a master and slave drive on the primary IDE channel and a master and slave drive on the secondary IDE channel, and it's going to query any drive it finds to get its appropriate parameters. Notice we have our primary IDE master drive, the hard drive we installed, and notice that we also have our DVD drive automatically detected. I strongly recommend that you set each of these parameters to the type of auto. Let the motherboard and the hard drive determine the best configuration. If you don't, you'll have to configure the cylinders, the heads, and the sectors per track for each of the hard drives you've installed in your system. How do you know what to put in there?
Well, take a look at the front label of the hard disk drive. It should list parameters for cylinders, heads, and sectors per track. However, if you have the auto option, just go with that. It's so much easier. Now, another thing you might need to do is configure the CPU. Again, this depends on the motherboard that you've purchased. Right here I have an option called CPU configuration. If I hit enter, notice that it automatically detected the type of CPU that I have installed in the system. I have a 2.5 gigahertz Pentium 4 CPU. My motherboard was smart enough to be able to go out and query the CPU and find out what its parameters are. What kind of CPU is it? What frequency does it run at? What's its multiplier rate? On other motherboards, you may have to manually enter this information. If you do, look at your motherboard documentation, look at your CPU documentation, and you'll be able to come up with the correct parameters to use for the given CPU. Now, another thing you might need to do is come over here and determine which video adapter we're going to use. Now remember, on this motherboard, I already had an onboard AGP video board that was built into the motherboard, but I said I don't want to use it because they generally don't perform as well as the one that's installed in a slot. So what I need to do here is make sure that this option is set to auto. If I select it right here, it's going to ignore the AGP board that I installed and use the onboard one. If I set it to auto, it will default to the board that's installed in the expansion slot. Now you can also configure your onboard devices. What I need to do here is to configure the serial ports. This one is currently set to use IO address 3F8 and use IRQ4. That works just fine. This parallel port is configured to use IO address 378, and it's set to use a mode called ECP. There's many different modes you can configure your parallel ports. We're not going to go into them right here. If you have a particular device connected to your parallel port, such as a scanner or a printer or even a parallel hard drive, check the documentation and see which mode it recommends. We're going to stick with ECP for now. Now, I'm not worried about my game port or my MIDI port, so I'm going to leave those disabled. Here's my parallel port IRQ. I could change that if I wanted to, but I'm going to leave it at 7. I want my network adapter enabled, so I'm going to leave that on. And I also want my soundboard enabled, so I'm going to leave that on as well. Another thing we need to look at is the boot settings. In other words, what device do we want to boot the system from? You can boot the system from a floppy disk, you can boot it from the hard drive, or you can boot it from the CD-ROM drive. Now notice right here we're set to boot from the floppy disk first, from the hard disk second, and from the CD-ROM drive third. Now there's a little bit of a problem here. We need to install an operating system. We're going to install Windows XP, in fact. The problem is the fact that in order to do that, we need to boot off of the CD drive, or the DVD drive. Now, with this ordering set the way it is, the system will hit the floppy drive first, then it's going to hit the hard disk drive and probably kick up an error saying, I can't find an operating system, before it ever tries going to the DVD drive. So to fix that, I'm going to come down here, and I'm going to press the minus key. It says the minus key right here, change option. Okay, so I moved my DVD drive up to the top of the list. Okay, so now it's going to look for boot files on the DVD before it looks on the floppy and the hard disk, and I do want that. So I'm going to press escape, and now I have made all the changes that I need. I'm ready to go ahead and save my changes. That's done using the F10 key right here, save and exit. That will write this information to the chip that we call the CMOS chip. So I'm going to press F10. We're going to save our changes, and we're off and running. With the BIOS configured, we are almost ready. The next thing we do is partition the hard disk drive and install an operating system. Now, this is a mistake that's made by many folks, especially when they're reading their system and adding a new hard disk to the...
They do everything right. They set the master-slave relationship. They plug in, put the driving system, turn it on, and assuming an operating system, they boot it up and they say, where's my new drive? All I see in the drive, where's the new D drive that I just installed? Well, the mistake they make was that they didn't partition and format the hard disk drive. Now, when you're installing the operating system for a new hard drive, it's not as big an issue because the installation for Windows and Linux and most other operating systems give you the opportunity to format and partition the drive before install on it. We'll look at how to do that in just a minute. Before we do that, let's talk about what a partition. A partition is a logical division on the hard disk drive. You could make 1, 2, 3, or different partitions on your hard disk drive. Now, operating system, each of those partitions is going to look like a separate drive. So if I took a single hard disk drive and on it, I would have a C drive if I'm running Windows, and I would have a D drive. Now, with each partition you create, you must format it. Now, the process of it is dependent upon the operating system. If you're going to be running Windows, you're going to format it using one type of file system. If you're going to be using Linux or some other operating system, you're going to need to format your partitions using type of file system. What it does is create a file allocation table, and it also creates the root directory. With that in mind, let's talk about the role operating system. What you need to understand is that applications that you run on your computer have no idea how to interact with the various hardware components. The role of your operating system is to sit between the hardware of your PC and the applications that you want to run. In essence, the operating system provides a platform or an interface for the applications to run. Let's get how we go installing Windows XP. What I have done is placed my Windows XP Home Edition CD in my DVD drive. Remember, when we configured our BIOS, we configured it to boot off of the DVD drive first. I powered the system on, and it booted off of our Windows XP Home CD. And that brought us to this screen, the Welcome to Setup screen. It says to set up Windows now, press Enter. So we're going to go ahead and press Enter. And then we have our licensing agreement. Please understand that software vendors make their money and their ability to continue to produce software based on the fact that people pay for it. So I would strongly encourage you to read the Windows XP licensing agreement and obey it. I'm going to press F8 to agree to the licensing agreement. Now I need to partition and format my drive. Notice down under Windows XP Home Edition Setup it says unpartitioned space on disk 0 on our IDE controller. I want to create a partition in the unpartitioned space. To do that, I'm going to press the letter C. So I press C and it says create a new partition using all the space. I'm just going to press Enter. Now notice that a new partition, partition 1, drive C, has been created. I want to install Windows XP in the selected partition, so I'm going to press Enter. And then we're given various options for formatting that partition. We can format the partition using the NTFS file system, or we can format the system using the FAT file system. FAT is much older, it's not nearly as powerful, it doesn't use things such as permissions. We want all the features provided by NTFS, so I'm going to go ahead and arrow to format the partition using the NTFS file system, and then I'm going to press Enter. Now we wait for a few minutes while that partition we just created is formatted. And by the way, when you're doing this at home, especially with a very large hard disk drive, the formatting process takes a long time. Okay, the partition has been formatted. Now if you look at the bottom of the screen, you see a message that says creating a list of files to be copied. Windows XP for the next few minutes will copy the files it needs from the CD over to the new partition on our hard disk drive. So we're going to wait while that happens. Now we have to restart the computer. When it does, it will restart in Windows mode. Okay, our system is restarted. It's booting up. Notice we're now in the Windows graphical environment instead of the text-based environment that we were before. We'll wait just a minute for everything to load. Now notice over here on the left side of the screen is kind of a progress indicator telling you where you are in the installation process. We started collecting information, updating, preparing the installation. We're now at the installing Windows phase. Notice down here it tells us approximately how long it will take to complete the installation. In this case, we have about 39 minutes left.
Alright, we're at the regional and language options screen. By default, Windows XP uses United States English for its installation language. In addition, it uses the US standard keyboard layout. If you need to change any of these, you can click Customize here or Details here. For what we're doing, the defaults work really well. They probably will for you too. So I'm going to hit Next. Now you need to type in your name and your organization. Put my organization as the company I work for. I'll go ahead and hit Next. Then we need to enter our product key. When I purchased this copy of Windows XP, I received a product key on my Certificate of Authority. I'm going to type that in here. Now, I'm going to type in the wrong one because Microsoft would be really upset with me if I were giving out a legitimate product key. So I'm going to type in the wrong one, stop the camera, put in the right one, and then start up again. TT4. And then I hit Next. At this point, we need to set up our computer's name. I would suggest using something that's fairly descriptive. I'm going to set this computer's name to Build Your Own Computer Demo. And then I'll hit Next. I check and make sure that the current date and the current time are correct. And then I need to set my time zone. We're located in the Mountain Time Zone. And then I'm going to select Next. In this screen, we can configure our networking settings. We're going to go with typical settings for now. And I'll hit Next. Alright, our Windows XP Home operating system is installed. It's ready for you to install your favorite applications and get to work. Excellent. We have a running PC system with an operating system. We have built our own PC. You can now go in your bathroom, look at yourself in the mirror and say, man, am I cool or what? I built my own PC. I want you to understand what a valuable skill this is. You can do anything you want with this skill. You could build your own PCs. You could build PCs for friends. I've known people that have built PCs for profit. They've started small businesses building PCs and selling them to customers. You can do that. Before we can finish up, there's one more thing we need to talk about, and that's the concept of burn-in. Now, usually, 99.9% of the experience, PC components work very well together. Even though you bought your motherboard from one vendor and your CPU from a different vendor and all your boards from a variety of other vendors, everything seems to plug in and work pretty well. However, there are occasions, and I had this happen a year ago, where something just isn't right. The system boots up and everything seems to run, but then you start noticing little flakinesses in the system. In my case, it was a bad motherboard. What you need to do is run what's called a burn-in test. Now, there's many different types of burn-in tests. You can actually purchase software that will run a full-bore burn-in test and actually stress the components in your PC to identify anything that might fail first. If you're building PCs professionally to sell to people, you probably should do that because you want to be absolutely sure that those components aren't going to fail on your customers. I think you'll find that building your own PC is just a lot of fun, and you get a great sense of satisfaction from using something you made with your own two hands. Thank you for joining us in this video. If you would like to learn more, please visit http://www.nebo-tech.com on the internet and see what other offerings we have available. About every month or so, you'll see a new title posted. Thanks again, and good building!